In this video, I want to take a look at an introduction to capture recapture. So capture recapture is a statistical method used to estimate the size of a population. And how do we do this? Well, we take two samples of the population and we compare those samples. So to begin with here, let's just state the formula then that we use for capture recapture. So the formula here for capture recapture is given as C over P. We've got C over P, and that is equal to T over R. So T over R. So the C over P here, that's taken from the first sample that we take. And then we've got T over R here, and that comes from the second sample that we take. So what do these four variables represent here? So we've got C over P and T over R. Well, C here, that's the number that we capture in our first sample. So I'm just going to call that captured here. That's captured. Then we have P here. So P is what we think is the total population. So we just call it P. So that is the population. Obviously, we don't know that when we begin these questions, and that's what we're looking to estimate. That's for the population. We then got our second sample here. Now, before we take a look at what T and R represent here, we just quickly discuss capture recapture. The way that it works is we take our first sample. We might catch, say, 20 fish. So let's say we're looking at estimating the number of fish in a lake. If we catch 20 fish in our first sample, what we do is we mark those 20 fish. So for example, we might just leave a little bit of dye, a non-toxic dye on the fish. And then we release those back into the river or the lake, whatever we're looking at. And then we take the second sample. And with that second sample, what we're looking at basically is checking how many that we capture have the dye on. So this is where we get T and R now. So T here, that's how many are tagged. When we say tagged, all we mean there is the number of the animals that we're looking at, for example, that have, say, the paint, the dye, or like a little tag on. So just so we know which we marked in the first sample. And then what we have here is R. So R here is how many we actually recaptured in total. So let's say we caught 100 fish, and let's say 5 had the dye on. Then T would be 5 in that case, and R would be 100 if we caught 100 fish, for example. Okay, so that's how many we recaptured. Okay. So recaptured there. So that's the formula that we're going to use. It's not the easiest to remember, for example, but I think once you kind of look at a question, take a look at a quick question, you'll see that it's not actually too bad to work with. Obviously, we could rearrange this formula here. But in this case, if I want the population, in this case then, P is given as C times R. That's all divided by T. So we'll see that in practice in a moment. We're going to take a look at a quick practice question. But before we do that, we just need to be aware of the assumptions that we work with for capture recapture. So let me just clear the screen here. So the assumptions, we've got 3 assumptions here mainly that we work with for capture recapture. So I'm going to quickly run through each one of these. So my first assumption here is that the mark or tag doesn't affect the chance of survival. So obviously, if we're looking at animals, if I put a dye on this animal or a bit of paint, for example, basically we don't want that to affect the chance of survival. So obviously, if they're out in the wild, if I put a big bright color on that animal, it might increase the chances that it's hunted or it gets, caught by a predator. We don't want that, so we don't want it to affect the chance of survival. That's our first assumption there. The second assumption here is that the mark or tag hasn't faded and is still visible. So for example, if we're looking at fish in a lake, for example, if I'm putting a little bit of dye on, obviously I don't want that to fade by the time I take the second sample. That's the other assumption there. And then finally, we're looking at the population being closed. What we mean by that is there's no change in the population size. Okay. So those are the 3 assumptions that you should be familiar with here. You can be asked for these assumptions, so just take note of these. They will pop up, every now and then when working through capture recapture questions. So that gives us a bit of an introduction there. So what we're going to do now is just take a look at a quick practice question here for capture recapture. If we take a look now at this practice question here for capture recapture, we're going to work through this together. They've got Sally who wants to find an estimate for the number of fish in a lake. She catches 32 fish from the lake and she marks each one with a distinctive die. So in this case, this is the tag that we mark those fish with. Sally then returns the fish to the lake. A week later, Sally returns to the lake and takes another sample of 50 fish from the lake. So in this case now, our total recapture would be 50, and of those 50, 4 of these fish are marked with a distinctive die. I want to work out an estimate for the number of fish in the lake. So let's just put everything together here. So remember the formula here that we use for capture recapture is going to be C over P, and that's equal to T over R. Okay, so how many did we capture here in our first sample? Well, we caught 32 fish. So C in this case would be 32. So I've got 32 over. So it's up to you what you use here to represent the population. You could just use P for population, that makes sense. I just use X to represent the population here, but it's completely up to you what variable you use. I've got 32 over X because obviously we don't know the population size yet. That's what we're looking to find an estimate for. I've got 32 over X, and that's going to be equal then to T over R. Remember, T here is how many were tagged. Well, there's 4 of these fish that have the die on. That's going to be 4. And how many did we recapture here? Well, we caught 50 fish, so it's going to be 4 over 50. Okay. So always remember the order that it goes here is the first fraction represents the first sample, second fraction represents the second sample. It doesn't have to be in that way, or in that order, I should say, but I find that it helps just keep it first sample, first fraction, second sample, second fraction. And what I'm going to do here now is just rearrange this and solve for X. Okay. So I've got 32 over X equal to 4 over 50. Obviously, you could simplify this right-hand fraction here. That would be 2 over 25. That's absolutely fine. Not necessary, but you can do that. So what I'm going to do here to begin with is times both sides by X. Get rid of this denominator here of X on the left-hand side. I'm going to get 32 is equal, this would be 4X over 50. What I'm going to do now is times both sides by 50 here. Get rid of this denominator of 50 on the right-hand side. So 4X in this case equal to 32 times 50. So 32 times 50. What I'm going to do now is divide this by 4 because I just want X on its own here. So therefore, X is going to be equal to 32 times 50. And then we divide that by 4. Okay. And in this case, if you just evaluate this here, we get 400. Okay. Remember, I used X here to represent the total population size. In this case, then, the estimate for the number of fish in the lake is 400 fish. So estimate them. That would be 400 fish. Okay, so 400 fish. And there we have it. So, like you can see, actually using the formula for capture recapture isn't too tricky. It's just remembering the way that this fraction goes. Same again for the second fraction, and then just rearranging to solve for the population. Okay, there we have it. So that brings the end of this video on an introduction to capture recapture.